All right, so square root functions, first of all, are functions that contain, the square root of a variable. So for example, this is a square root, this is the parent of a square root function, so root x. You could have, the square root of 2x plus 1, the square root of x minus 5, and so on. Okay, if this is the parent function, f of x is equal to the square root of x. Let's use a table of values to graph root x so we see what it looks like, okay? All right, so if this is x, and this is y equals root x, or actually it's f of x equals root x. I'm going to plug in values of x here. It's kind of distracting. Okay, I'm going to plug in values of x here, okay, and reproduce the graph over there, right? So let's start with x equals 0, all right? Y would be the square root of 0, which is what? 0. Okay, now, can I now try x equals -1? Right, so x equals -1 would mean that I get the square root of -1, and that can't work. In fact, can I use any of the numbers on the left side of the y-axis? No. So what about x equals 1, though? That will give me root 1, which is 1. So next, right, I can put in x equals 2. But what would that give me? Root 2, which is an irrational number. I would rather have whole numbers. So I would rather have numbers in the x values that are perfect squares. That way I can take a square root of them. So 1 is a perfect square. After 1, what is the next perfect square? 4. And root 4 will be 2. And I can put another one. What's the next one? 9. And root 9 would be 3. So when x is 0, y is 0. When x is 1, y is 1. When x is 4, y is 2. And when x is 9, we finally make it up to 3. And this looks like that. So as the numbers increase, this is not going to level up, right? Because as you go to x equals 100, right, the square root will be 10, and then x equals 400, the square root will be 20. If x equals 900, the square root will be 30. So it's not going to level up. It's going to increase, but very gradually. Okay. So now let's do this one. What does that plus 2 do to the graph? Move it to the left 2. Right? So, in the parent function, the square root started at x equals 0. Now, if the plus 2 moves it to the left, what is the starting position now? -2, right? So the starting position now is going to be -2. So why don't we do a little chart, a table of values. The first number I'm going to put in is -2. And I'm going to get the square root of -2 plus 2. How much is that? 0. All right? Are we okay? Yes? Okay, now, next, can I plug in -3 into here? If I plug in -3 for x, what do I get? The square root of -1, right, if it's -3. If I plug in -3, then I don't write this just yet, then I get -3 plus 2, which is -1, right? And does that work? No. So I can't do that. So I can't go to the left. That means I got to go to the right. So if -2 is my first point, what else can I plug in? -1. So let's plug in -1 and see what that gives me. -1 plus 2, 1. Huh? It's I root 2. Okay, so now, what if I plug in 0 for x? I get the square root of what? 2, and that's not a fun number at all, okay? So what I want is, I want numbers that give me perfect squares, right? So if I plug in a 2, I get what? Is that a good one? That's a good one. So root 2 plus 2, that gives me 2. Root 4, which is 2. Okay? What else can I plug in? That will give me 7, because if I plug in 7, then the square root of 7 plus 2 is what? 3. Okay? So I think this is good enough. Let's just plug these in. So at negative 1, I'm going to get 1. I'm sorry, not there. At 2, I'm going to get 2. And then at 7, 3. Let me draw this and I'll answer some questions. Let's talk about domain and range. All right, for domain, we need to scan the x-axis horizontally and see where there is a graph, right? So if I start scanning this way, if I scan horizontally, the graph starts where? At where? At -2, and does it ever stop? No. So it's x is greater than or equal to -2. All right. Well, what about the range? I have a first time it's y is 0 and it goes up. So y is greater than or equal to 0. So I'm scanning the y-axis for the range, right? The first time I hit a graph is here. 0. And as I increase up, I'm going to have graphs the whole time because this is gradually going up. So it starts at 0 and goes up. So it's all the y values that are greater than or equal to 0. All right. Let's do this next one. What does the -2 do to the graph? Shifts it to the right 2, and what does the 1 do? Move it up 1. So the original was supposed to have its starting point at 0 at the origin. Now it's going to go to the right 2 and up 1. So right there. So instead of it starting at 0, it's going to go to the right 2 and up 1. All right? Let's plug in some values. Okay. Now, the first one, right, is x equals 2. So I get the square root of 2 minus 2 plus 1, and that's 1. All right, what else can I plug in here that'll give me a perfect square in the square root? How about x equals 3? Right, 3 minus 2 plus 1. What will that give me? 2. What if I plug in x equals 4? Will that be a good one? No? Yes or no? No? What else would be a good one? Brian says 6. What do you guys think? So 6 minus 2 gives you 4. And the square root of 4 is 2 plus 1 is 3. 10. Will 10 work? So if I put 10 for x, I get 10 minus 2 is 8. What else? 12. So 11, but that's off the axis. So you know what? Let's just be satisfied with this one. So x is 2, y is 1. X is 3, y is 2. X is 6, y is 3. And we just give it that general shape. Okay? Now, what's the domain? I have an x is greater than or equal to 2. Anybody want to give me a different answer? So I start, right? The first time I hit a graph is here at x equals 2, and then I will have a graph everywhere. So x is greater than or equal to 2. What about the range? What's the first time I hit a graph? Y equals 1, and it's going to be all the values greater than or equal to 1. Any questions? All right. So here I have 3 times x minus 5. What does the minus 5 do? To the right 5. So if the number is inside, you set x minus 5 equals to 0, then x equals 5, right? So it goes 5 to the right. So basically, if it's inside with the x, you have to go like opposite to the sign. If it's negative, it goes in the positive direction. Yeah. All right. So it's going to start at 5, 0 here, right? Okay. So what numbers can I put in my number line that'll give me some good values here? So 5 will give me 0. What if I put in 6? Then I have 3 times 6 minus 5. Okay, so hang on. So this is 3 times, what's the square root of 6 minus 5? 1. So it's just 3. What else can I put in that'll give me a good one here? 9. So let's put in a 9. That'll be 3 times 9 minus 5. So it's 3 times, what's the square root of 9 minus 5? 2. How much is that? 6. So when 6, we have 3. Okay, and look at that. What did the 3 do you think? It made it so much higher, right? Wider. Okay. All right. So let's do domain and range then. Where would the domain start? At x equals what? 5, and is it greater than or less than x equals 5? Greater, so x is greater than or equal to 5. So on the test, I need to see x for domain and y for range. Well, what about the range? Y is greater than or equal to 0. Square root graphs will never be all reals because can you just plug any number into a square root? No, you can't have negative numbers in there. So it'll never be all reals. Okay, what about this one? So what does the plus 4 do? Where does it move the graph? Left 4 and the 6 down. So left 4, down 6. All right, so in my chart, in my table of values, I'll start with what? Negative 4. So this is negative 4 plus 4 minus 6. How much is that? 0 minus 6. So here, right, I have negative 0 minus 6. Okay, what else can I put in the chart? Can I put negative 3? Negative 3? Well, let's try to put negative 3. See what we get. Right? Negative 3 plus 4 minus 6. Here I get negative 1 minus 6. How much is that? Negative 7. Now, can I put in a minus 2? If I put a minus 2, what do I get in the square root? 2, and I don't want root 2. So what if I put 0? Can I pick 0? What do I get in the square root? Right, 4 minus, so it's negative 2 minus 6. Negative 8. What else? Can I put a 1 in the square root? 1 plus 4 gives me a 5. What about 2 plus 4 gives me a 6? So I need a 9. What should I put? A 5. Huh? Where? So 5, it'll be negative 5 plus 4 minus 6. So negative 3 minus 6 is negative 9. Okay, so negative 4, negative 6, negative 3, negative 7, 0, negative 8, 5, negative 9. Whoa. All right, so you see what this looks like? It's like a reversed comma. Sort of, right? Okay, now, where's our domain? What do you guys think for domain? Where does the value start? What's the first time we get a graph? Negative 4. And where does it go? The greater numbers, right? So what do I write down here? Okay, now take a look at the range. As I'm going up here to here, do I have a graph? Yep, here, 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 here. What about here? Here? No graph, no graph, no graph. So where is the graph? It's at y equals negative 6, and does it go above or below? Below. So y is less than or equal to negative 6. All right. So this here is just a revisit of transformation. So like we've seen these all the time. Remember for the parabola, what was it? It was y equals a x minus 8 squared plus k, right? Do you see how it's the same? You have an a, now instead of a square, you have a square root, x minus 8 plus k. They all follow the same format, and every single time, this h number is responsible for the horizontal translation, right? So the h number is always responsible for the horizontal translation. The k value is always responsible for the vertical translation. And the a value gives you the orientation and shape. So basically, if you have a negative, if a is less than 0, it's reflected around the x-axis. There is a vertical dilation, it's stretched, it's compressed, and so on. Okay? Now, this is the homework due next time.